Today's notes are on solving absolute value equations and inequalities. First, we need to know the definition of an absolute value. The symbol for absolute value is two vertical lines. An absolute value is the distance a number is from zero, or the difference of two numbers. Let's look at example 1 below. It asks us to solve and graph the solution. The first thing that we want to do is get the absolute value sign by itself. So we're trying to isolate this part right here, which means I need to get rid of the 5 and the 2. So we're going to start by subtracting 5 from both sides. We're left with 2 times the absolute value of 3x minus 4 is equal to 10. Still trying to get the absolute value by itself. I need to get rid of the 2, which means I'm going to divide. And I'm left with the absolute value of 3x minus 4 is equal to 5. From here, I'm going to set up two equations. I'm going to set up the equation 3x minus 4 equals 5 and 3x minus 4 equals negative 5. When you are solving absolute value equations, you will always set up two equations, one with a positive and one with a negative answer after you isolate the absolute value. From here, we're going to go through and solve each equation separately. So I'm going to start by adding 4 to both sides to get 3x is equal to 9. Then I'm going to divide both sides by 3 to get x is equal to 3. On the other side, I'm going to once again add 4 to both sides and divide by 3 to get x is equal to negative 1/3. These are my two answers. In order to graph them, I would take my number line and I would graph 3 as a point, and I would graph negative 1/3 as a point. I don't need to draw an arrow or shade in either direction. Please pause the video and try example 2 on your own. Now we can look at solving absolute value inequalities with inequality symbols less than or equal to. To do this, we want to start by isolating the absolute value. Then we're going to make it a compound and inequality with the negative value on one side of the symbol. For example 3, we need to start by getting the absolute value by itself, so we're going to add 2 to both sides. To get the absolute value of negative 2x plus 6 is less than or equal, not less than or equal to, less than 24. Then, because my absolute value symbol, or my absolute value is isolated, I need to create a compound and inequality, which means I'm going to have one long inequality with two inequality symbols. I need to flip 24 to be a negative value, so I'll have negative 24 is less than negative 2x plus 6, which is less than 24. So this whole part here is the same as above. I've added another less than symbol, and I've taken the 24 and I've made it negative. Now we want to go through and solve for the center part, trying to get x by itself, remembering that whatever we do to one side, we need to do to all three. So if I start by subtracting 6, I need to do it from all three sides to get negative 30 is less than negative 2x, which is less than 18. Then I'm going to divide everything by -2. And we need to remember that when we divide by negative, we also flip the inequality symbols. So I will get 15 is greater than x, which is greater than -9. Next, we're going to draw in our number line. And label some points, so we need to know where -9 and 15 would be. Because these are greater than symbols, we're going to use an open circle. And because it's a less than inequality, we should know that we're shading in between the two numbers. Please try example number 4 on your own. Now we're going to look at example 5. We're going to start by trying to get the absolute value by itself, which means that I'm going to add 4 to both sides to get the absolute value of 2x plus 9 is less than 11. Then I'm going to set up a compound inequality by making the 11 negative and putting it on the left side of my equation with another less than symbol. So again, the only part I've added onto my equation is the -11 is less than. The side should look exactly the same now that we've isolated the absolute value. We're then going to separate it into 3 areas and try and get the x by itself in the middle. So we're going to subtract 9 from both sides, or from all 3 sides rather, to get -20 is less than 2x, which is less than 2. We're then going to divide everything by 2 to get -10 is less than x, which is less than 1. This is my solution. I now need to put it onto a number line. So we're going to draw our line here. I'm going to make sure I include the values -10 and 1. Once again, I'm using open circles because they're less than and not less than or equal to. And because it's a compound and inequality, we're shading in between the two. Please try example 6 on your own as well. We are now going to use a compound or inequality. We're solving for absolute values that are greater than or equal to. So our first step is the same, to isolate the absolute value symbol. The second step is to make it a compound or inequality, where on the second equation we flip the symbol and we use a negative value. So looking at example 7, I want to start the same way by getting the absolute value by itself. So we're going to add 9 to both sides to get 3 times the absolute value of x minus 5 is greater than or equal to 15. And then going to divide both sides of the equation by 3 to get the absolute value of x minus 5 is greater than or equal to 5. Now that I have the absolute value by itself, I'm going to set up 2 inequalities. The first one is going to stay exactly the same. X minus 5 is greater than or equal to 5. We could also have the equation x minus 5. I'm going to flip the symbol, become less than or equal to, and I'm going to use the negative value instead, so we'll have negative 5. I am now going to solve each of these equations on their own. So the first one, I'm going to add 5 to both sides to get x is greater than or equal to 10. Then I'm going to add 5 to both sides in this second equation to get x is less than or equal to 0. And we want to put it on a number line. So I have 0 and 10. Because I'm using less than and greater than or equal to, we should know that we are going to have filled in circles at these values. And we have x is less than or equal to 0, so it's going to be shooting off to the right. And x is off to the left, sorry. And x is greater than or equal to 10, so that'll be shooting off to the right. We can also remember that our compound or inequalities should be pointing different directions on our graph. Next, let's scroll down and, pause the video, try example 8 on your own, and then scroll down to look at example 9. Example 9, I'm going to start by adding 1 to both sides to get the absolute value by itself. We'll have the absolute value of 3x minus 2 is greater than or equal to 8. From here I'm going to set up two equations, one exactly the same that says 3x minus 2 is greater than or equal to 8, and one where I flip the inequality sign to get less than or equal to, and we're going to set it equal to negative 8. Then we're going to take each equation and solve for x, so I'll need to add 2 to both sides to get 3x is greater than or equal to 10. I'm then going to divide both sides by 3 to get x is greater than or equal to 10 over 3. Or if I solve the other equation, going through the same steps, adding 2 to both sides, and dividing by 3, I get x is less than or equal to negative 2. The last thing I need to do is put this on a number line, and I want to make sure I include the values negative 2 and 10 over 3. They're both going to be closed circles because they're less than or equal to and greater than or equal to. So I have x is greater than or equal to 10 thirds, so it points to the right, and x is less than or equal to negative 2. That graph will point to the left, or again remember that they point in different directions. Please pause the video, try example 10 on your own. We will go through the 4 examples that you tried on your own tomorrow in class.